Hey everybody, this is Dr. Jacobs. Welcome back. This week we're going to be learning more about fundamental research issues. So there are some things that I want you to be able to do by the end of this unit. First, I'd like you to be able to distinguish among the four types of experimental validity. I'd like you to be able to recognize threats to the construct, internal, external, and statistical conclusion experimental validity, and offer quality solutions to remediate those threats. I want you to be able to distinguish among confounding, independent, and dependent variables. I want you to be able to identify when to use different statistical techniques. I want you to be able to distinguish between random assignment and random selection. I also want you to be able to define experimental control. All right, so there is a lot of materials that were not included in this week's chapter. And so there's going to be a lot of materials that I draw from other sources to help define some of the things that we're learning about in this chapter and also provide you ways to be able to learn the content more in depth so that you can apply it to your research studies that you're going to be building. So there's a really good quote: the better the design of an investigation, the more implausible it makes competing explanations of the results. This comes from a Kasdan book that I used to use for my master's level research students. And what this is saying is the better that you design your study, the better that you carefully control different pieces of it, the better that you'll be able to talk about your results and it not be due to something else. So there's different things that we need to learn about. One of those is experimental design. And so a true experimental design is one that has at least two independent parallel groups and randomly assigns subjects to each of the groups and assesses the treatments prospectively. And so what this basically means is that you have at least two groups and you'll randomly assign your participants, which means you don't get to choose which group your participant goes into. You use a random number generator and you randomly assign which group your participant goes to. So if you're using a treatment group and a control group, you'll randomly assign them to each, and then you'll compare the effectiveness of those treatments on whatever dependent variable that you're examining. This is the only experiment or design that we can determine cause and effect. So a lot of times students will say, I want to know what causes depression, or I want to know if abuse causes depression, or things like that. And you can't actually do those studies because in order to determine if abuse causes depression, you would need to take a sample of participants. You need to randomly assign them to the condition to be abused and to a condition to not be abused, and then see if the group who is abused has significantly severe or more frequent prevalence of depression. And that's not ethical. We can't do that. So anytime you say the word experiment, I'm doing an experiment, you're actually insinuating or connotating that you're doing a true experimental design. So if you did not use a true experimental design, you cannot say you're doing an experiment, you're doing a research study. A lot of times people want to say different words that are synonymous with cause and effect to try to get away from using those words. So they'll be like, this impacted the score. Well, impact is another way to say cause or effect. And so it's really important to be mindful using that. Our book is actually really bad about using the word cause and effect with designs that are not experimental, even though they describe this in the book itself. There's also something called quasi-experimental design, and this is where you compare differences among naturally occurring groups. So if you wanted to see if there was a significant difference between people who were emotionally abused as children and those who were not emotionally abused as children, those are naturally occurring groups, right? And you can still see if there's significant differences, but we cannot say there's a causal link there. We can just say that there's significant differences. And in that case, because we have two groups and we're comparing two independent groups, because we use a between group design, we would use an independent samples t-test that you learned about in your stats class to analyze that type of data. So quasi-experimental design lacks that random assignment of participants to conditions that we talked about with experimental design. There's some variables that we need to be familiar with when working with research design. First is our independent variable, or for short, a lot of people call that an IV. And this is basically our grouping variable. A lot of times books like to define this as a thing that we manipulate as researchers, but we don't always use an experimental design when we're conducting quantitative research. And so I like to use it as our grouping variable, which can be applied to experimental designs as well. So if we wanted to determine if who has significantly greater reading levels, students who read during the school day only, or students who also read at home. We would have the different groups, people who only read at school versus students who also read at home. And that would be our different grouping variable. Our dependent variable then is what we're measuring in whatever study that we're doing. If you took statistics with me, you know that I consider measurement the process of turning information into numbers. And so for this will be whatever we're measuring. So if we're doing a study on depression, we might use the Beck Depression Inventory, which people call the BDI for short, to try to gauge someone's severity of depression, right? So in that study, our dependent variable would be levels of depression or severity of depression. Sometimes you'll hear people call the dependent variable the DV, and that's something that you'll want to get familiar with as well. We also have confounding variables, and this is something that influences our dependent variable other than our independent variable. If we're doing experimental design, a lot of times what we're wanting to do is see if our treatment has an effect on our dependent variable. And so if we have other things that are related to that dependent variable or can change it that are not related to our independent variable, then we call it a confounding variable because it can mess up or confound our results. So controlling for confounding variables. Controlling for potentially confounding variables minimizes the potential for an alternative explanation for treatment effects and provides more confidence that effects are due to the independent variable. There's a lot of things that we can do for this. And we'll actually talk about some things that might be confounding variables when we start talking about threats to experimental validity of our studies. But for example, there was a long time ago, and this is back, I think this article is back from 2013. There was a politician named Anthony Weiner, and he was going to run for mayor for the New York City. And there's this research that said that 78% of young women approved of Anthony Weiner, which is really interesting because Anthony Weiner at the time had gotten in trouble for sending unsolicited, inappropriate pictures to women. And so if you look at this headline, you see, oh, 78% of young women approve of him. And that's really interesting because that seemed kind of counterintuitive. And then underneath this is online dating service. And then you're like, oh, really? That many people thought about that. And then you go and read the article. And if you keep continuing here, it says a sugar daddy dating website, seekingarrangement.com, found that 78% of female clients aged 18 to 26 approved of Anthony Weiner, which is really interesting because this is people who are looking for like a sugar daddy, sugar baby type relationship. And so really it's not that 78% of young women approved of him. It was 78% of people on this sugar daddy, sugar baby website approved of this politician. And so it's really important because that's a confounding variable is that, okay, the approval ratings will change because these people are looking interested in power and money and things, and that's what they found within that actual study. We also have correlational designs. And this is where we examine relationships between variables. So for example, the Pearson product moment correlation examines the strength of the relationship between two variables on a scale. And these are things that you should have learned in your stats class. If not, make sure you're coming into my office hours and working through some of the stuff that maybe you hadn't learned. But we remember that scale means that it's data that's on an interval or ratio level of measurement. If you don't remember the levels of measurement, that's something you're going to want to revisit because a lot of the statistical analyses that you learned that we'll be using this semester in our projects require that your dependent variable is measured on an interval or ratio level of measurement. And if you don't know what that is, then you're going to have a lot of problems with your study as we design it, as we collect data and move forward. With correlational designs, you can only say that variables are related. You cannot determine causation with a correlation for several reasons. And you're just going to want to make sure that you don't try to do that because that's one of the biggest mistakes that people make in studies. So experimental validity, we're going to learn about four different types. They're called different names than what sometimes they're called out in the real world. So we're going to learn about construct experimental validity, internal experimental validity, external experimental validity, and statistical conclusion experimental validity. The book called it conclusion experimental validity, but typically you hear it called statistical conclusion experimental validity. And I actually have kind of a problem with most researchers saying it's experimental validity because these also apply to quasi-experimental and correlational designs as well. So I almost wish it was like construct research validity or internal research validity and so forth, but I didn't get to name it. All right, so construct experimental validity. This addresses the presumed cause or the explanation of the causal relation between the intervention or experimental manipulation and the outcome. So several features within the experiment can interfere with this interpretation, and we often call those confounding variables or confounds. So construct validity is sought by using well-established definitions and measurement procedures for variables. There's some other things that work as threats to construct validity, and we'll talk about those. But first, let's talk about what is a construct. So construct is an underlying concept that is considered to be the basis for or reason that experimental manipulation had an effect. So if I am doing a treatment on depression and say like it's some form of new type of psychotherapy that I invented and I wanted to see if it was effective, I would have a control group and an intervention group. I'd randomly assign my participants to conditions. The construct that I would be trying to determine if effective would be that intervention. All right, so there's several threats to the construct validity, things that mess with it. One could be attention and contact with clients, single operations and narrow stimulus sampling, experimenter expectancies, demand characteristics, and so forth. And we're going to go over these in a little bit more detail. So the book didn't go over these in detail, but you'll want to learn them because when you're designing your studies, you're going to want to control for some of these problems. Because when we're designing these studies, we're trying to get practice at becoming researchers and explorers so that we understand what's going on. All right, so attention and contact with clients. People don't know sometimes that with a study, if you're doing one in person, simply just providing attention and contacting the participants in your study can actually influence the results from it. And it may not be the effect of whatever intervention that you're doing, but because you provided that attention or that contact. And so there's also something called the placebo effect. Sometimes people believe just by getting some sort of treatment, so even if it's a sugar pill, that they're seeing an improvement in their symptoms. And we see that with a lot of those types of things that people think are effective, like essential oils or other things that may give a placebo effect. And so it's really important that, especially when doing research with humans, that we're controlling for the attention or contact with not just people who are receiving psychological and behavioral interventions, but with those who are not, that they're getting some sort of equivalent with the amount of time and attention that you're providing the people that are in the treatment group. Because if not, then it might be that attention and contact that is causing the changes in the dependent variable. So there's a whole bunch of different types of placebos so that people can have. There's a regular placebo, and the regular placebo has no effects or side effects associated with it. So often if we have like a pharmaceutical that we're running through a clinical trial, we'll have like a regular placebo sometimes where it's just a sugar pill and there's no side effects, nothing. They're just taking a pill and they don't know if they're getting the pill or not. An active placebo, though, they don't have any effects except for they mimic the side effects of whatever the actual treatment is. And so if you have a treatment, like a pill that you're trying to test the effects of, and it has one of the side effects is dry mouth, then the active placebo would have no other side effects except for dry mouth. And so then nobody knows if they're getting the placebo or the actual drug, so that hopefully the answers really represent what's going on. And so there's this really cool knee surgery study, and it's kind of out of control a little bit, but it was in the New England Journal of Medicine. And the article is called A Controlled Trial of arthroscopic surgery for osteoarthritis of the knee. And in the study, what they did was they had a treatment condition and they had a placebo condition. And for the treatment condition, they did this surgery. In the placebo condition, they actually numbed the area. They actually did an incision, but didn't do the actual surgery, and then stitched it back up. And then what they found that at any point, nobody in the treatment condition for this regularly scheduled surgery had better outcomes than the people in the placebo group. And so sometimes when I talk to students about this, they freak out and they're like, wait, is that ethical? And then you think, well, actually, is it ethical to give people a knee surgery that is not effective? And then, like, if we even think about that a little bit further, well, people thought they were doing better in the placebo condition just because they had that fake incision. And so it's really hard because then they don't have those same effects if they don't have the placebo, from that placebo effect. We also talk about masking and blinding. So when participants in a study are blind to their condition, that means they don't know if they're in the control group or the intervention. Many researchers like to use the word masked in place of the word blind to try to limit ableist language. However, it's not been as widely adopted as I've been hoping it would be. So you all need to know both of these language. It's double masked or double blind when both participants and staff are unaware of which participants are in which conditions. And that's ideal. So if you're having some sort of treatment condition, you don't want the people giving the treatment to know which condition the participants are in either, because then that can cause problems with things like demand characteristics and other things. So single operations and narrow stimulus sampling. And this was the experimental manipulation as conceived by the investigator was responsible for the results, or was it some seemingly irrelevant feature with which the intervention was associated? So with this one, what's it saying? Like, is it the actual intervention that is getting the results, or is it something like if you have cute packaging and it made someone happy, did the packaging actually cause the changes, or was it the actual intervention? Okay, so if we wanted to test the effectiveness of two different types of psychotherapy, what issue would we have if we had one therapist treat one condition and a different therapist treat the other? Okay, so let's think about this. So if we're testing two different types of psychotherapy, we have one therapist provide this one type of psychotherapy and another one provide the other. What would be wrong with that? Or what would be a limitation to our study if we did that? Okay, so if you said, well, one therapist might be more warm, right? One therapist might be more awake and alert. There might be characteristics of the therapist that are causing the changes and results for the clients or the participants, and that might not be related to the intervention at all. So that's something that might be a single operations and narrow stimulus sampling problem. We also have experimenter expectancies. So several studies showed that including or inducing expectancies in experimenters who ran the subjects through various laboratory conditions could influence the results. They call this the Pygmalion effect or the Rosenthal effect. And it's really interesting because this research actually started in education. And in this, what they did was they had teachers and they had students, and the researchers had students take these tests, and they told the teachers that, hey, these certain students scored really high on this test, this aptitude test. This means they're bound for really great things. They're going to do really well. They have a lot of growth potential. And so what happened is that the teachers were told that for that one group and not for the other. And actually that test didn't mean anything. What they found, though, was that teachers had higher expectations for students in the group that were told that they had this higher aptitude and skill level. And so the teachers raised their expectations. And for the students where the teachers raised their expectations, they found that those students started performing higher and meeting those expectations. And in one version of this study, they said, oh, no, we actually got it wrong. It wasn't these students that are going to be, it's these other students, where before they said they weren't going to be the ones that had the better outcomes. And then then we saw it flip. We saw that the teachers then had higher expectations for the students that now were in the group that had the higher aptitude or capacity for achievement, and those students achieved higher. And so we see the same thing in experimenter expectancies too, and expectations. So if you have certain expectations for subjects, a lot of times they're going to try to meet those expectations. One way to try to control for this is to automate as many procedures as we possibly can when designing a study. So if you're doing an online study, that makes it really easy to control the things that you're providing for your participants in your study, but it may also make it very difficult for whatever background and stuff, because then you're not controlling the environment in which people are taking their or completing the study in, unless you're having them come into a controlled computer lab area where you could control for things like that too. So there's also demand characteristics. Demand characteristics are like expectations in principle, but refer to how the cues of a study might prime, dictate, or influence the results. So includes sources of influence such as information conveyed to prospective subjects prior to their arrival to the experiment or study. This could be in the instructions, procedures, or any feature of the experiment. What I see a lot of times with students where they do this is actually in the informed consent, because we look at the informed consent and we have to provide information about the study so that people know about the potential risks and benefits for being a part of the study, like we learned within our ethics unit. But we also find that we can't tell them what we're looking for, because that could cause a demand characteristic and skew our results of our study. So this is something that, like, if we were in an in-person class, I would ask, what is the balance between providing your participants with proper informed consent without giving away your research question? So how do we find that balance? And that's something that you're going to want to think about when you complete your informed consent for the study that you're designing yourself. We need to properly inform our participants, but we also cannot give away our research question. We cannot let them know what we're looking for exactly. In the past, where I've done some studies where I was looking at like specifically, I think it was suicidality. I just said I was looking at mental health, right? If I was looking at different mental health, but I didn't want people to know that's what I was looking at, I might say, hey, I'm just looking at the experience of college students, and just make sure that I'm not asking questions that are going to cause harm any more so than just daily life. We also have we have internal experimental validity. And this refers to the extent to which an experiment rolls out alternative explanations of the results. So factors or influences other than an independent variable that could explain the results are called threats to the internal validity. So several of these threats include something called history, maturation, testing, instrumentation, statistical regression, selection biases, attrition, diffusion or imitation of treatment, combo of selection and other threats, special treatment or reactions of controls. All right, so history, this threat to internal validity. This is when things within or outside of the study that results of your study could be attributed to other than your independent variable. So history becomes a threat when other factors external to the subjects, in addition to the treatment variable, occur by virtue of the passage of time. So for example, if I was doing a study on germophobia and the prevalence of germophobia, if I was doing that study in March of 2020 and COVID happened and people became very hyper aware of germs and viruses and things like that, that would be a threat to the internal validity of my study. Although we could probably talk about what that looked like within that time period, that's probably not what it's going to be typically within society. So then maturation, these are when changes over time, such as wisdom or skill, influence the results and not necessarily your treatment. Okay, so the maturation threat can operate when biological or psychological changes occur within subjects, and these changes may account in part or in total for effects discerned in the study. So for example, if there's decreases in childhood asthma, if you're doing a longitudinal study, which is a study over a long period of time with the same participants, these decreases as a child age could be just that they're growing out of their childhood asthma, not that the treatment was effective. So these are certain things that you would need to be mindful of when designing a study. Also, testing is a threat to the internal validity of a study. And this is when retesting of participants itself results in changes in the dependent variable. A lot of times this will happen when you do a pre and post test. So if you're doing a pre and post test over a period of a week, this might cause some problems with your study because it might just be that they learned the test and that they didn't actually learn the content. This is especially true when the pre and post test are identical to one another. And a pre-post test design, if we just have one pre-test and one post-test, what kind of statistical analysis would you use to analyze that type of data if your dependent variable is on an interval or ratio level of measurement? If you don't remember from your stats class, you're going to want to make sure that you're checking in with me, that you're coming into my office hours so I can help you out. That kind of analysis would be a dependent samples t-test because we would be using a within group design where we use both the participants in both levels of the independent variable or both groups. And so we would use the dependent samples t-test for this. So if the results are just because they took the test twice, that means a lot of times that they just learned the test rather than having real changes in the knowledge that they have. There's different ways that people will try to account for this in a study. One way that they do this is they'll often do two equivalent forms of the pre and post test where they do the analyses to make sure they're equal difficulty in tests, but not the exact same test. There's also instrumentation, and this is when study results are due to changes in instrument calibration or observer change rather than a true treatment effect. And so one way to do this is standardize the instructions for the measures and procedures. If you have multiple raters, so like sometimes like you might have multiple people doing some form rating, you establish something called inter-rater reliability before allowing them to assess the quality. So this basically is a procedure where we get all the people that are judging whatever quality on the same page. I notice this sometimes when I'm grading papers, actually. Like when I first start grading really hard papers, sometimes I'm really hard in the beginning. And as I get through more papers, I have a better idea of what is meeting the expectation, what's not, or like which things align which criteria a little bit better because I have a little bit more practice. And that's why a lot of times what I'll do in my classes is I'll hide grades for major papers and I'll go through and grade twice, or I'll at least grade all my papers and then go back and make sure that I'm writing out what I'm taking points off for and how many and the rationale, and then I'll go back and regrade until I calibrate all of them together. If in like the real world, a lot of times people police officers actually will calibrate the breath alcohol test before they test somebody with a breath alcohol test when they suspect them of being drunk while they're driving. And they do that to make sure that the instrument is on par, it's doing what it's supposed to do, and that it's actually due to the person being drunk, not because the machine was messed up. We also have statistical regression. Sometimes you'll hear this referred to as regression to the mean. So if you get extreme scores the first time that you measure something, a lot of times if you remeasure it, it'll move closer to the mean score, so it wouldn't be as extreme. If we were in an in-person class, I would do something called the mind reading test, and I do this example. And I'll be like, okay, everybody, and y'all could play along with this right now at home, but I'd be like, okay, you got to read my mind. We're going to do a test to see how clairvoyant you are. And I would think of numbers in my head, and I can write them down now. Let's write down some numbers. And it'd be like, okay, I'm going to think of a number in my head, and you're going to write down what number I'm thinking of. And I'd say, go. And you write that first number down, then you write your second one down. And we do a list of 10 of them, right? So I thought of my first number, thinking of my second number now, thinking of my third number now. I'm thinking of my fourth number now, thinking of my fifth number now. I'm thinking of my sixth number now. I'm thinking of my seventh number now. Thinking of my eighth number now. my ninth number, and my 10th number. And so we'd come back as a class and I'd read off the numbers that I was thinking in my head. So if you actually did this with me, you could write these down. So the first number was 5, 2, 3, 4, 4, 5, 6, 7, 8, 10. And then I'd have everybody in the class write down how many they got right. I find the students with the 2 worst scores, be like, okay, you're not really good at mind reading. So let's go do an intervention. And I'd make something up. I could make them do patty cake or spin in a circle one way, or spin in a circle another way. And I'd be like, okay, there you go. You've had your intervention. And then we go back and do that process again, just with those 2 people who did the worst. And then I do it again and I just make up 10 numbers and have them read my mind. And then what's really interesting about that is every single time I've done this, the second time that the students have done it, they've always done better than they did on the first time. And that just illustrates something called regression to the mean, where we have the tendency, if we get an extreme score on something, the second time we take that test, a lot of times it'll move closer to the average or the mean. We also have selection bias, and this occurs when groups are unequal in whatever quality prior to the introduction of the independent variable. This is one problem for quasi-experimental designs because we're not randomly assigning participants to conditions. So a lot of times if we're randomly assigning our participants to conditions, we assume that our groups are equal at the beginning. That may not always be the case, but that's actually one of the reasons why we randomly assign our participants to the different conditions. So again, it's particularly problematic for quasi-experimental designs because we don't randomly assign our participants to those conditions. Attrition is another really big threat to the internal experimental validity of our studies. And this is when participants quit the study or they just decide they don't want to be a part of it anymore. And this is especially problematic if we have some sort of experimental design or any design really, and we lose more participants from one condition or another. I guess that would be a problem in any kind of study, even a quasi-experimental design. And so if we lose too many participants in an entire study, then that kind of skews our results. So we have to problem solve, okay, what ways do we think we can get participants completely finish the study? And thinking back to some of the ethical issues that we learned in our last unit, where we can't coerce participants can quit the study at any time without retribution. And we can't force them to, and we can't have incentives that are so large that it makes students or participants have to participate in it. So it's really important to test to see if there are certain demographics that are similar in participants that are dropping out of the study. So if we're doing a study and we're looking at significant differences in attitudes on something, and the different groups are based on race ethnicity, if we have one group of race ethnicity that drops out more than the others, then we're going to want to know that. And so we're going to want to do the analyses necessary so that we can determine that. This is also a threat to other types of experimental validity as well. So it's something that you really want to be mindful of. Something that I do a lot of is making sure that, like, when I have the different forms, if I'm doing online research, that I have some sort of logic that says, hey, you missed this one. Do you want to finish this question before you submit or something like that? That helps a lot too. We also have diffusion or imitation of treatment. And this is when you're doing some sort of treatment or intervention study and the treatment somehow gets leaked to the control group, or somehow the control group just starts doing the intervention on their own. It's mimicked within the control group somehow. I remember going through graduate school and someone was talking about their dissertation and they were doing these behavior interventions in schools. And what they found is they randomly assigned some teachers to the intervention to help with behavior and then other teachers to the control group where they didn't have it. And what they found throughout the study is that there's no differences in the behavior. Like, there's no significant differences in the behavior problems that the teachers were seeing in the control group versus the treatment group. And what they ended up finding out is that the teachers that were doing the intervention were seeing significant decreases in these bad behaviors in their classes. So they started teaching their friends these interventions that were in the control group. And so the control group was actually doing the intervention too, which is why there wasn't a significant difference between the groups. So this is something really important to pay attention to if you're doing some sort of treatment or intervention, that the control group doesn't somehow end up getting the intervention as well. We also have special treatment or reaction of controls. And there's two different ones that we're going to talk about. We're going to talk about the John Henry effect and also the Hawthorne effect. So the John Henry effect, this is when the control group knows that they're the control, so they don't act like they normally would. So either they outperform what they normally would do or underperform what they would have done naturally. So it's really important that the control group and the treatment groups don't know what they are in. So again, blinding or masking means that participants don't know what condition they are in, and double masking is actually ideal, where not only the participants don't know, but the people who are the research assistants or the people providing the treatment don't know either. So again, double masking or blinding means that the participants and administrators of the intervention don't know what condition they're in. Hawthorne effect, then, participants behave differently simply because they're participants in a study. This goes for both intervention and control groups. And that makes sense. Like if you know you're being watched, then you might not act as naturally as you would typically. And so that's really unfortunate, and that's a really hard thing to get around. So then we have the external experimental validity as well. And this refers to the extent to which the results of an investigation can be generalized beyond the conditions of the experiment to other populations, settings, and conditions. So what is a one-word summary of what external experimental validity is? And you should have learned about this in your stats class. It would be generalizability. So in inferential statistics, like the ones that we're going to be using for our project, the goal of it is to take a sample from a population so that we can make guesses or infer guesses about what's going on in the overall population. And so generalizability is the ability to apply your results from your sample to the population or to other populations in setting and context. So when we're doing these studies, we're going to have a method section, and within our method section, we're going to have different subsections that we're learning about. So we'll have a participant subsection, a procedures subsection, a measures subsection. But in our participant section, we're going to talk about our inclusionary criteria for our study. And these are key features of the target population that the investigators will use to answer the research questions. So if I am doing a study on people with depression, and I want to examine suicidality in people who are depressed, one inclusionary criteria might be that my participants have a DSM diagnosis of major depression. Let's say that's inclusionary criteria based off of it could be a formal diagnosis, right? Or I might have there's a certain cutoff of depression that participants must have on the Beck Depression Inventory to be included in the study. Okay, so it's whatever the inclusionary criteria. Often it could be that they're 18 because you're wanting to study adults, right? So 18 plus, and they're just whatever you're wanting to examine. Exclusionary criteria then are defined as features of the potential study participants who meet the inclusionary criteria, but have other additional characteristics that could interfere with the success of the study or increase the risk for an unfavorable outcome. So for example, in that study, if I'm looking at depression, I might want to include people who are depressed, but I may not want to include people who are taking antidepressant medications because that could really confound my results depending on what I'm examining. Or maybe I want to look at people who have depression who are taking fluoxetine, which is commonly known as Prozac. If so, then these are things that I need to outline specifically when I'm creating my study, so that I know who my target population is and who, if I have this target population, who I will exclude if they meet the inclusionary criteria for whatever reason. And so you're going to describe your participants. That's something that we're learning in the APA manual as well, in our method section, and not just the inclusionary and exclusionary criteria, but we want to describe different demographic things that the APA manual talks about, typically things like age, race, ethnicity, just a whole bunch of different things that we will need to collect, right? And we're going to need to create a demographic form to ask our participants these questions so that we can include it into our study. So we have some threats to the external experimental validity. We have sample characteristics, narrow stimulus sampling, reactivity of experimental arrangements, test sensitization, multiple treatment interference, novelty effects, generality across measure setting and time. So sample characteristics, this threat to the external validity is that the extent to which the results can be extended to subjects or clients whose characteristics may differ from those included in the investigation. So again, generalization is applying the findings of your study to the population of interest or other populations. And it's really important, again, that we're utilizing some sort of demographic form. So by demographic form, I mean, we're going to ask our participants, how old are you in years? What's your race, ethnicity? What's blah, 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 right? That's related to our study so that we can describe. Also, those are in our APA manual readings that we're doing. So if you're not doing those readings, you're going to want to make sure that you are. Because you're going to have to describe your participants and you're going to need to know which questions ask. And you're going to show that to me in your IRB application. You're going to show that to me in your paper that you create for this class. And so something that's interesting, and before we get into that last point, is a lot of times a lot of research is conducted with college students as being the participants. And a lot of that is because classes like this, research methods, will use participants who are in like gen psych classes for the participants in their studies. And that allows us to get easy access to participants. But at the same time, that's also problematic because then we only have one type of population. There's a whole article written by Jeffrey Arnett talking about weird populations, and I'm going to butcher the acronym for it, but we're just saying that there's a lot of studies that are done on westernized, educated people from these individualistic cultures, and they may not apply to everybody around the world, which is a really big disservice. Also, if we fail to randomly select our sample, then we cannot generalize our results back to the population we're interested in studying. So earlier we learned about random assignment, which is where we randomly assign which condition our participants go to. That is separate from random selection. Random selection deals with how we get our sample from the population we're interested in studying. If you remember, we have several different sampling methods. We have random selection, we have convenience, or random sampling, convenience sampling, and snowball sampling are some that we've learned about. Random sampling is when everybody in the population has an equal chance of being selected into your study. A lot of times you're not actually going to get that. Typically, at least even for this class, we're going to be using convenience samples where we're going to get participants because it's easy to get those participants so that we can go through these training research exercises together. But doing that limits our ability to generalize our results back into the people that we're interested in studying. We also have reactivity of experimental arrangements. And this is the extent to which subjects are aware that their behavior is being assessed and that this awareness may influence how they respond. Persons who are aware of assessment may respond differently than how they would if they are unaware of the assessment. So one of the things that this deals with is called social desirability. When participants believe that they'll look better for responding a certain way, then they're probably going to respond in that way. A lot of times people may not want to admit to doing drugs. So if you're doing a study about drugs, they may not respond in a way that actually reflects their behaviors, but in a way that makes them look good. We also have demand characteristics, which we started talking about before, but this also plays here as well. And this is some sort of hint that allows participants to figure out what the research is studying. And if that happens, that can skew our results too. So we want to be really careful that we're not doing these things. We also have reactivity of assessment. So we have obtrusive measures, and this occurs when a participant knows that they're being assessed. And reactivity of assessment occurs when assessment causes a participant to act differently in the research study than in real life. We also have test sensitization. Pre-test sensitization happens when the pre-test impacts the participant's response to the intervention. So for example, if you have a pretest of violence before a violent movie, that may prime the participants to experience the movie differently. This means that the results may not generalize to people who have not been given the pretest. We also have post-test sensitization, and this happens when the post-test impacts the participant's response to the intervention. If sensitization increases the impact of an intervention, that might actually be a good thing, right? And it might be worthwhile to actually incorporate that post assessment as part of the intervention, actually create it as part of the intervention if it's going to help the intervention be successful. We also have multiple treatment interference. Some research designs utilize multiple treatments. And when they do that, that can make it kind of difficult to interpret the results of a study. We also have novelty effects, and this is when an intervention is effective because it's new or innovative rather than because it's actually the intervention that's being effective. Sometimes effects of interventions wear off over time, and that's because it's not new anymore. So we also have an example. So at one point they like, oh, let's paint fire trucks neon pink. Like maybe people will pay attention more to the fire trucks if they're neon pink and not get in as many accidents. And at first it helped a lot. But after a while, what happened? After a while, people got used to the fire trucks being neon pink and it just became a regular part of life. So it kind of wore off. We also have generality across measure, setting, and time. And this is the extent to which the results can be extended to other measures, settings, or assessment occasions other than the ones that were included in the study. So our last type of experimental validity that we're going to talk about in this lecture is statistical conclusion experimental validity. Sometimes you'll hear this referred to as data evaluation experimental validity. And unfortunately, this type of validity is often neglected when studies are being planned and executed. Do not make this mistake. Hopefully you're still here with me taking notes because this is going to be really important because we had statistics as a prerequisite to this class because it's going to be expected that you're going to apply that information to these studies in real life that we're going to be doing. And so when we're looking at this, you're going to want to keep in mind when you're designing your studies, things about measurement, things about the different things that we're going to talk about here, because if you don't, then it's going to mess up the results that you get. So statistical conclusion validity pertains to the extent to which data from a research study can reasonably be regarded as revealing a link or lack thereof between independent and dependent variables as far as statistical issues are concerned. So basically what this is saying is that this type of validity, that your study should be regarded as it really showing that there's that result or not result based on some of the statistical issues that we're going to get ready to talk about. So again, it looks at if statistical analyses were appropriate and also if they were done correctly. So the quantitative research process, which we're learning about in this class, which we'll be doing in this class, a lot of times we're going to write our formal research question. This is going to be typically a question that could be answered in a yes or no. And we're going to use that and we're going to align that with particular statistical analyses that you learned previously to answer our formal research and null hypothesis to see which one that our data supports the best. So after we read our formal research and null hypotheses, we're going to determine which statistical analysis we're going to use to test this hypotheses. If you took stats with me, this is a little bit different than what we learned. This is more putting into context what we would do in the real world. You'll note that I put the research hypotheses before the statistical analyses. And that's because we're not worrying about just running statistical analyses. Here, we're worried about creating a research question, creating our research hypothesis, and then using the statistical analyses to analyze which one our data supports the best. Then we collect our data, then we run our results using software. If you're from my stats class, you're probably cheering that you don't have to do it by hand. And then we're going to write up our results. All right, so there's some threats to our statistical conclusion validity, such as low statistical power, subject heterogeneity, variability in procedures, unreliability of measures, restricted range of measures, errors in data recording, analysis, and reporting, multiple comparisons and error rates, misreading or misinterpreting the data analysis. And these are some of the different ones that we have. So statistical power, what does the phrase increase the power of the test mean? So it means to increase the chances that you'll reject the null hypothesis if the null hypothesis was false. The most common threat to statistical conclusion validity is low statistical power, which we'll talk about. Because there are several ways that we can increase statistical power. One is to increase our sample size, which means we get more participants. Another way is to use a one-tailed test, which means writing our hypotheses directionally if we can. Another way is to use parametric analyses, which is the plan for this class, to use one of the parametric analyses that you learned about in stats class. Another way is to increase the alpha level. That one's a little bit tricky though, because there's only two commonly accepted alpha levels. So we have an alpha level of 0.05 and 0.01, and we can't go beyond that. So I really like this question. And is it ethical to subject participants to any procedures as part of an investigation if that investigation has very little likelihood of detecting a difference, even if there is one? So what this is saying, or what this is asking, is it ethical to conduct a research study if you don't have enough power for your test? And as a professor, as someone who guides people into doing research and hopefully the right way, I'd say, no, that's not ethical at all. You shouldn't be wasting subjects' time if you're not going to find results that can be that will be accurate. Because if you don't have a sufficient sample size, then if the power is too low, even if you should reject your null hypothesis, you won't, because it wasn't powered enough. So power analysis is something that must be completed prior to conducting a study. Basically what this is there's a software called GPower, which I have the link in this presentation for, where you put in what statistical analysis you're using, what kind of effect you're looking for, and it pops out a minimum sample size that you need to have. So this is that link. You can find it in the Google Slides that you can click on to download the software. There's also a tutorial there. There's also a lot of tutorials on YouTube as well for it. And this is something that must be completed as part of your study this year. And so when we go, you'll see what a minimum sample size that you will need to be part of your study to find results. Something that you're going to want to keep in mind too is that you might have people who attrition out of your study. What does attrition mean again? If you remember, attrition means people dropping out of your study. So you're going to want to kind of give yourself a little bit of wiggle room. So although you have a minimum sample size, you're going to want to shoot for some more just in case people drop out of your study. And we also have type 1, type 2, and type 3 errors. A type 1 error is when we incorrectly reject our null hypothesis. And so this can happen for several different reasons. A lot of times they call this an alpha error because what that means is that your alpha level is too high. And so you rejected your null hypothesis because of that. We also have a type 2 error, and this is when we incorrectly retain our null hypothesis. Often they call this a beta error. And that is because there's a formula for power of the test, which is 1 minus beta. And beta is the probability of making a type 2 error. So the power is the opposite of that. It's the power of your test is the probability of not making it a type 2 error. And a lot of people want to power their studies at 0.80 or 80%. A lot of times I'll try to power my studies up to 95% or 0.95 because I want to reject my null if I can. There is a bias within research that they typically only publish studies that have statistically significant results. And if you get a type 2 error, then you're not going to have statistically significant results, even if it would be in the population you'd study. Then type 3 error, this may be new for a lot of you all because this is more deals with the research methods types thing than stats. But this is when you find that your results are statistically significant. So we find that there's a significant difference, but the differences are actually really, really tiny. The only reason why you found those differences is because you had a really huge sample. So it didn't take a whole bunch to find statistically significant results. We also have subject heterogeneity. This is differences within a sample that introduce variance within the data set that's not due to your independent variable or your IV. What does the prefix hetero mean? It means different. So when we look at this, when we're looking at heterogeneity, we're saying that the participants are different from one another in a ways that influence our independent variable. The more diverse that your sample is, the less likely that you're going to find significant differences, which we're hoping to find typically as researchers. So this is why we want to narrowly define our populations to what we're wanting to study. And then your study can always be replicated with other samples later on. So in general, case, the greater the heterogeneity or diversity of the subject characteristics or your participants' characteristics, the less likelihood of detecting a difference between the conditions. Critical to the statement is the assumption that subjects are heterogeneous on a characteristic that is related to or correlated with effects of the independent variable. All right, so also variability in procedures. If you fail to standardize your procedures, you introduce more variability into your data set. So for everything that you're going to do, you're actually going to talk about the procedures of your study within your method section of your paper or of your project, and so in here, you're going to want to standardize. You're going to want to say the step 1, step 2, step 3. If it's a study that's being done in person, you're going to want to have a script of the exact things that the person's going to say, who's collecting the data. If you're doing an online study of some of some sort, those directions will be standardized because they'll just be read by the participants, or if you have an audio component where it's read to the participants. But it's a lot easier to standardize your procedures in online studies. Also, if you have unreliable measures, and we're going to be getting into measures really soon, if you have measures that are not consistent, then you're going to have major problems with the statistical conclusion experimental validity. The differences in your results could be because your measures were not consistent. And if you remember, reliability just means consistency of your measure. So if you are wanting to take someone's temperature, you want the thermometer to be reliable. You want it to be consistent. If you take it and it says you have a temperature of 104, you take it out, wait 30 seconds for the thermometer to get back to normal and put it back in, and then it says you are 96 degrees, that's what your temperature is. That's not reliable. It's inconsistent, and you can't trust that data. Also, restricted range of measures, and again, we're going to get into measurement and measures in detail, but something you have to make sure is that there's enough of a range in the scores that the measure allows us to detect if there are differences. If it doesn't, if it's super restricted, then we're not going to be able to tell anything. Also, errors in data recording, analysis, and reporting. So any errors in your data set, analysis, and or reporting, whether intentional or unintentional. This happens a lot with hand entered data. It was really sweet because my dad actually helped me quite a bit when I was working on my dissertation. He served as like my research assistant while I was working during the day. I had collected all my data on paper because sometimes it's easier to get participants to complete your study if you're there in person, and they're more likely to participate, which helped me get the sample size that I needed for my dissertation. And so my dad input all of the data into an Excel sheet so that I could export it over into SPSS so I could analyze my data with statistical software. And I programmed the Excel sheet. He didn't just do it once, he went through it twice because on 2 different sheets. And what it did was it checked for entry errors. So if the 2 cells didn't match for the participants, it flagged it in red. And we knew we had to go back and make sure that there wasn't an error, which I thought was really cool. I don't know if I could program it to do it now, but younger me had that going on. Also, multiple comparisons and error rates. The more comparisons that we make, or the more statistical analyses that we run, it increases the chances of making a type 1 error. And we can look if we run one statistical analysis, and we have alpha level of 0.05, the probability of making type 1 error is 0.05. Now, if we make 3 comparisons, it goes up to 0.143 or 14.3%. We make 6 comparisons, it's 1 in 4 rate of having a type 1 error. And so when we do this, there's different things that we can do. If we're trying to compare 3 groups, then we're going to just use an ANOVA, if you remember. So if we have 3 or more groups that we're wanting to compare on one dependent variable, we're going to use some form of ANOVA to look for significant differences. If we are really needing to do more than one statistical analysis, we're actually going to do something called Bonferroni's correction, and we're going to actually adapt our alpha level. So if we're going to make 3 comparisons, we take our alpha level of 0.05 and divide it by 3 to see what our new alpha level would be that we would compare our p-value to see if we have significant results. Also, misreading or misinterpreting the data analysis. It's really important to understand what results mean when using software to analyze the data. This is why statistics was a prereq for this class. This is also something students struggle with too. So if you need help with this, please utilize my office hours. That's why I have it. That's why I have a huge desk, and chairs. And if you can't come in, we can always try to do a Google Meet of some sort. I may even, if people are interested, do some meetups in Lee Summit for Lee Summit students, since I live in that area. Maybe we can meet up at a coffee shop a couple times too. So if that's something you're interested in, let me know in an email so I know that's something that people might be interested in doing. So that's our references for the day. I know this is a lot of information. It's really important to realize that you're never going to have a perfect study. And I know I went through all these different things of ways that things can be wrong, but when we make one decision about one thing, sometimes it can cause problems in different areas. But what we have to do is just try to critically think about our studies, more reading research, make sure we're critically thinking about the research that we're reading and these different threats to these different types of experimental validity. And that makes us stronger researchers. There will always be something that you do wrong. The only way to get better as a researcher is just to do it. So you're going to want to make sure that you're paying attention to these lectures. I know they're hard. I know research can be kind of tricky, but I know y'all can do it. And this is really exciting because at one point, you'll probably get to a point where you get really excited about research and finding solutions to problems and just investigating. And that's at least my hope for you all. And I look forward to seeing what we come up with as we progress through the semester. So I hope you have a great week.